Yes, sir.
Okay,
Thank you, sir.
thank you. Just one query. It is visible, sir?
Yes, sir. It's visible, sir.
Okay. Okay,
Yeah.
now I will start. So, good afternoon to all. Um as sir introduced, my name is Hemant Bari, and today I'm going to discuss on a totally different topic. Means last 3 to 4 days, you must be listening lectures on energy management, how to save the energy, how to generate the products in less energy, energy efficiency, energy audit, and lot of things. Beside that, one more important topic is there that I'm going to introduce with you. That is condition monitoring. What is this condition monitoring? How it is applied or how it is operational at ADTPS or India? A lot of plants means every plant needs the condition monitoring. So what is this topic? Some of you will be well known about this topic. Some people may not be known about this topic. So I'm starting with the different basics, and I will just introduce you today what is condition monitoring, why it is necessary, what are the benefits of condition monitoring, what are the different topics or different subjects or different areas of condition monitoring, and along with that, one or two new technologies which are upcoming in condition monitoring, and how to implement at college level, how to pass on to your students, how to do the PhD in this subject, and followed by 2 to 3 case studies. So let us start with the introduction to condition monitoring. I will request this now. Condition monitoring. Condition monitoring offers diagnostic information and data for the root cause analysis. Condition monitoring is used as a proactive defect elimination strategy to drive failure prevention, and the benefits add up with the improved reliability, giving extended mean time between failures. These are all Google definitions. Difficult to understand. Simplifying this in our own language, what is the condition monitoring? Condition monitoring is this. Condition monitoring is simply similar job to the doctor's job. Whatever the doctor performs with our body to find out the root cause of abnormality in our uh, operating body, or similarly, we have to also find out the problems in the machine by analyzing the data. Take an example of doctor. If you have some kind of problem, say there is a problem in your stomach, okay, you have been talking to the doctor, and now the doctor asks you certain questions, means he asks history from you. Means he will ask आपने क्या खाया था, क्या पिया था, कहाँ गए थे, and some kind of these questions. If this problem is persisting from how many days, is the history is there, 6 महीने पहले भी हुआ था क्या? Similarly, some questions he will ask. After getting some answers from you, he will decide some test based on your symptoms. Okay, and after the test results and the data collected from you verbally, he will finally conclude you are suffering from this disease. आपको ये बीमारी है, and there is a solution. So every disease has a solution, and unless and otherwise doctor confirms, you cannot take direct medicine. Similarly, in a condition monitoring also, on a regular basis, from a machine, you collect vibration, temperature, pressure, ultrasonic, motor current, oil analysis, and all other process parameters. Just like a human body, each and every parameter has a limit कि आपका शुगर इस रेंज में होना चाहिए. Blood pressure has some range. Some other parameters have their range. Okay. Similarly, each and every condition monitoring parameter of a machine has ISO standard limit. Means the temperature is 60 degrees centigrade, and that particular bearing has warning at 80 and tripping at 90. You will say my machine is healthy because the temperature is 60, well below the limits. If the temperature is 82 degrees, my machine is at alarm level. I should monitor it closely and find out why it is on higher side. If that temperature is around 89 or 88, oh, it's very close to the tripping limit, I should stop the machine because something is wrong in my machine. Similarly, any deviation in any parameter, you have to immediately look after that machine. So whatever the doctor performs with our body means collecting the data from you, performing the test, and finally analyzing the data for the root cause analysis. Similarly, here also we collect the data on regular interval depending upon the criticality of the machine, and any deviation in any parameter we have to look after that, why it deviated, because of alignment, because of bearing damage, because of foundation, or any other cause. So whatever the deviation you will get, you have to confirm the fault. Once you confirm the fault, immediately the maintenance team will work on that particular machine, and after that you have to recheck the machine whether the fault is eliminated or not. So this is condition monitoring job. It is a completely the doctor's job. Now the flow of presentation will be, I will introduce the condition monitoring, condition based maintenance using the various condition monitoring techniques. Then we will see various CM techniques with the case studies, summary, and conclusion. Now, simplifying that difficult definition here also, a complete solution to machinery maintenance is condition monitoring philosophy. What is condition monitoring philosophy? A complete solution to machinery maintenance by effectively implementing the condition monitoring techniques. So it is very important, whatever the problem is with your machine, or whether all the parameters are normal. Sometimes what happens, you feel something problem with your body, but you get a total body checkup and the doctor says no deviation is there, you are absolutely correct, absolutely okay. Similarly, the condition monitoring data also indicates if all the parameters or all the values of different parameters are well within the limit, you can simply conclude there is no maintenance required for this machine and you can run the machine, no need to stop the machine. And if there is any deviation, then you have to find out why it is deviated and which part is getting deteriorated or which action has to be performed on that particular machine and after how much period. Okay, so that trend will help you key how much time it will take to deteriorate a tentative, not the fix. Okay, now here the two important words are there: effectively implementing, because I have just explained you a complete solution to machinery maintenance by condition monitoring techniques, but effectively implementing is very important. I'll give you an example. Suppose there is a problem in your leg. Okay, there is a problem in your leg, you have been taken to the doctor, and doctor, what a good doctor should go for first, a blood test, x-ray, or sonography? Of course the x-ray, because there is a bone problem, primarily he can see, and he should go for a x-ray first. So why x-ray first? Because looking at the symptoms, you should find out the root cause of abnormality. You should select such an appropriate technique so that the root cause of abnormality should be identified at early stage. Suppose थोड़ा सा उल्टा सोचिए, what will happen आपके पैरों में दर्द है, यू हैव बीन टेकन टू द डॉक्टर एंड डे 1 ओके ब्लड टेस्ट ले लो, डे 2 गो फॉर अ यूरिन टेस्ट, डे 3 सम अदर टेस्ट एंड डे 4 ओके आज एक्सरे निकाल लो. What happened in these 3 to 4 days? The pain increase or decrease? Of course, increase. The secondary damages will increase. Some other problems may arise due to that leg problem or that internal problem, whatever is there. So, what I'm going to say that though you have a lot of techniques available to perform or lot of technique has to be are available for a particular area, you should select appropriate technique, such an appropriate technique so that the root cause of abnormality should be identified at early stage. उसी जगह पे आपको 102 fever है, what will happen? You should go for a blood test whether there is a malaria, dengue or any other fever is there. You will not go for X-ray 102 fever. If there is a आपके पेट में दर्द है, you will go for sonography. You will not go for a X-ray because that unnecessary data will not serve you, will not help you to find out the abnormality. Similarly, for the machines also, lot of condition monitoring techniques are available, but looking at the symptoms, which parameter deviated, मेरा वाइब्रेशन बढ़ा है क्या तो मैं फेज लूंगा, मेरा टेम्परेचर बढ़ा है क्या तो मैं थर्मोग्राफी करूंगा, मेरा गियर बॉक्स से आवाज आ रहा है, आई विल गो फॉर ऑयल एनालिसिस एंड सच काइंड ऑफ थिंग्स. Okay, so looking at the symptoms, you should select appropriate test. पैरों में दर्द है, you should go for a X-ray. Fever है, go for a blood test. Okay, like that. So सारा techniques का data जरूरी नहीं है. Whatever the parameter is deviated, you should select appropriate technique to find out the root cause of abnormality as fast as. जितना जल्दी आप fault find out करोगे, you will be able to save your machine, able to save the secondary damages to your machine, and ultimately ये सारा cost में calculate होता है. Okay, so a complete solution to machinery maintenance is by effectively implementing the condition monitoring techniques. Now, what is our aim? Our aim is zero breakdown. There should not be a breakdown. Yes, there will be a deterioration. Yes, there will be a damage to your machine parts, internal parts, or some other parts such as bearings or coupling no, bushes. But machine breakdown nahi hona chahiye. I will give you an example. Over the period of time, the bearing deteriorated, accepted. लेकिन shaft में crack आ गया उसकी वजह से not accepted. Motor bearing damage, accepted. Motor जल गया, not accepted. Gear teeth worn out over the period of time, accepted. But gear teeth broken, not accepted. So there should not be a breakdown. Over the period of time, you monitor properly machine, and as the deterioration comes in that particular machine, you should be able to detect the fault at early stage. Now, reduce maintenance. With the help of condition monitoring, always there will be a less maintenance you have to perform. Suppose some machine is running at a 4.5 millimeter per second vibration and the limit is 7.1, and you measure the vibration 6.5. 4.5 से 6.5 हो गया means some kind of deviation has occurred. Due to what reason? I will say alignment disturb. आपने उसी टाइम पे अलाइनमेंट कर लिया तो आपका कपलिंग का बुश बच जाएगा, बेयरिंग के ऊपर एक्सेस लोडिंग नहीं आएगा, एंड इट विल टेक योर मेंटेनेंस टाइम 6 आवर्स और 5,000 रुपए मैन एंड मटेरियल कॉस्ट आ गया. सपोज यू इग्नोर दैट कंडीशन मॉनिटरिंग डेविएशन, 6.5 का 7.9, 7.9 से 8.4, 8.4 से 11.2, 11.2 से 14.6, 14.6 से 17.1, and lot of things will happen just because of ignoring the condition monitoring deviation. अभी आपको कितना खर्चा आएगा? My motor bearing damage, my pump bearing damage, my coupling bush damage, coupling foundation bolts deteriorated, and due to excessive vibration the pipes also damaged. It will cost you 5 lakhs rupees man and material cost, and 6 days your machine is unavailable. So which maintenance you will prefer? I always give the example of our finger. You must be seeing this finger on your screen. Okay, इस फिंगर में समझो एक डीप कट लग गया. Okay, and if you put a 10 rupees bandage immediately and properly take care किया, in 3 to 4 days the finger will be okay and everything will be okay. You will be available for the work, college, or your whatever. How much खर्चा है? 10 rupees. But if you ignore the deviation, अरे कुछ नहीं होता है, धूल जा रही है, मिट्टी जा रही है, इन्फेक्शन हो रहा है, वायरस इन्फेक्शन हो गया, बुखार आ गया, एंड ऑल दिस थिंग्स हैपन, एंड इन्फेक्शन आपके हाथ में या बॉडी में फैल गया. 4 days admitted, lot of injections and salines and medicines and all these things. 10,000 rupees man and material cost means 10,000 or 15,000 to hospital charge, and you are completely unavailable for 1 week. Which maintenance you will prefer? So immediate action, timely action for any deviation is very important, and that will always help you to avoid the secondary damage. Increase the machine reliability. Suppose my all condition monitoring parameters are well within limit, it gives you the confidence, yes, my machine has no deviations, I will run this machine so for some more period. If you run the machine for some more period, productivity will increase, the profit will increase, and ultimately to help maintenance cost center into the profit center. Now whatever the maintenance डिपार्टमेंट को खर्चा नहीं करना पड़ा ड्यू टू कंडीशन मॉनिटरिंग, दैट इज योर प्रॉफिट. मींस यदि हमने सही टाइम पे अलाइनमेंट कर लिया तो बेरिंग का खर्चा नहीं करना पड़ा, दैट इज द मेंटेनेंस डिपार्टमेंट प्रॉफिट. So this is our aim: zero breakdown, reduce maintenance, increase machine reliability, and ultimately to help maintenance cost center into the profit center. Now condition monitoring objectives. What are the different objectives? Whatever I have discussed in scattered way with the doctor example, leg and this and all these things, I have put in a correct technical language. Now what is the prime objective? Access the condition of machine and detect the fault at early stage. जितना जल्दी fault find out करोगे उतना ही आपको benefit रहेगा, मशीन के बारे में हो या आपका ह्यूमन बॉडी के बारे में हो. So for the machines, access the condition of machine on regular basis and detect the fault at early stage. Diagnose the root causes. This is a very prime of means backbone of the condition monitoring objective. एक एग्जांपल देता हूं कि सपोज यू हैव बीन सफरिंग फॉर मलेरिया, डॉक्टर हैज डिटेक्टेड यस यू हैव बीन मलेरिया, ये 3 times या सुबह शाम आपको ये टैबलेट लेना है, सिरप लेना है, व्हाटएवर, एवरीथिंग इज डन, and the doctor told you that the root cause of malaria is mosquito, so stay away from the mosquito, cover with a mosquito net and close your doors in the evening and all these things. So you followed all the instructions, you took the tablets, followed all the instructions, fever will go, okay, fever will disappear from your body. But आपने मॉस्किटो नेट नहीं लगाया, विंडो ओपन रख दिया और सुबह में और रात भर ऐसे ही सो गए, what will happen? The mosquito will come and bite you again and again, malaria. So root cause elimination is always necessary. For a condition monitoring also, always diagnose why this bearing failed. 5-year operation, okay, aging accepted. 2 months operation, not accepted. Alignment disturb, accepted. But किस वजह से अलाइनमेंट डिस्टर्ब हुआ, that has to be found out. कि वो बोल्ट शेयर हो गया या कपलिंग के बूस्ट डैमेज हो गए over the period of time. So this kind of root cause elimination is always necessary. Otherwise, the problem will recur. Reduction in unplanned outages. There will not be unplanned outage. There will be always a planned outage you can take, because you know with the help of condition monitoring data which machine is getting deteriorated, which machine has a deviation, or which machines do not need any kind of maintenance. Advanced planning of spares and procurement. This is a very important aspect or condition monitoring objective. The critical parts are manufactured by the OEM, that is the original equipment manufacturer. So whenever they do not keep ready all the parts. Whenever you give them order, they start the manufacturing, and after giving that manufacturing time maybe the 4 to 6 months. So for the critical machines, if you monitor the condition monitoring data very precisely, then you can tell the maintenance department well in advance that you start the procurement process. By the time that product receives you at your plant, you can always tell them for the replacement. And that time, that manufacturing time, you can continuously monitor the machine and keep a close eye. Extension of equipment life, just like a vehicle. For your car, you are taking care of your tires, battery, engine, and servicing and all these things. What will happen? The whole things, whatever you are doing, will be benefited to your car, and the car belongs to you. It will never fail in middle of the road, middle of your journey. So here also, if you are taking care of motor, it taking care of pump, taking care of bearings, taking care of foundation, taking care of coupling, the whole equipment will be benefited. The equipment belongs to your plant. The plant will be benefited. There will not be an unplanned outage, unplanned breakdown, and continuous running will be there of the plant, and ultimately the production will not halt at under any circumstances. So condition monitoring has a vital role. Reduction in secondary damages. There will not be a secondary damages, already explained, because if you detect the fault at early stage, there will not be a secondary damages. Eliminate the catastrophic failures. Catastrophic failures will be eliminated. What is the difference between damage and catastrophic failures? Damage means you can repair and reuse that part, but catastrophic failures you cannot repair or reuse that part, and lot of means it is a kind of accident only. So that has to be avoided, and condition monitoring has a capacity. Condition monitoring had that much of power that catastrophic failures will not happen if you do the condition monitoring properly. Now, after explaining this much, you will say, why should I go for a condition monitoring? नहीं करूंगा. I am a mechanical engineer, or I am an electrical engineer, I am a civil engineer, or I am some kind of other engineer. I have 80%, I have 85%. Why should I go for such kind of new topic, and why? So the answer for this is, you today's industry, we call it as a 4.0, that is the 4.0 or 4.0. This is a modern industry, this is an advanced industry, this is a futuristic industry. Nobody will allow you to open any machine. एक बोल्ट भी खोलने नहीं दिया जाएगा unless and otherwise you justify your boss, you justify your top management, you justify the organization. Suppose you will say, sir, एक साल हो गया हम लोगों ने इसका अलाइनमेंट नहीं किया है और अब मैं अलाइनमेंट कर देता हूं. Nobody will allow you. सर उस ट्रांसफार्मर का ऑयल 3 साल हो गया है, बदला नहीं है, अभी बदल देता हूं. सर उस गियर बॉक्स का ऑयल 4 साल हो गया है, विल रिप्लेस दिस. Nobody will allow you. सर इसका बेरिंग 5 साल हो गया है, आई वांट टू रिप्लेस इट. No, you are not allowed. You will be allowed if you justify the management, if you justify the organization or your boss. Sir, इसका वाइब्रेशन 2.5 चल रहा था, अभी 6.5 हो गया है, and it shows a misalignment in the machine. Immediately all resources will help you. Sir, इसका acceleration value 2.1 था, अभी 4.6 हो गया है, indicates a bearing damage. You are allowed to replace the bearing. सर इसका ऑयल कंटामिनेशन 10% था, अभी 60% हो गया है, आई वांट टू फिल्टर द ऑयल. You are allowed it. Who will tell this data? the condition monitoring data. So without a condition monitoring justification, you are not, आप कितने भी बड़े मैकेनिकल इंजीनियर हो या इलेक्ट्रिकल इंजीनियर हो, you are not allowed to do any kind of maintenance on your machine unless and otherwise you justify or specify why you are opening this or why you are replacing that. So that is why the condition monitoring is very, very important. Now, secondly, in today's competitive world, for the, you can pass on this to your students also. In this competitive world, if I say I need 10 mechanical engineers, how many applications will reach there? More than 1000 or 10,000. So किसे सिलेक्ट किया जाए? Suppose 100 भी एप्लीकेशन आया तो किसे सिलेक्ट किया जाए? I cannot absorb all the 100. I need only 10. So I will search among that 100 कि सारे मैकेनिकल इंजीनियर से एक्सेप्टेड, इट्स अ कॉमन थिंग. फर्स्ट क्लास वाले मैंने ले लिया, सारे फर्स्ट क्लास है तो भी चलेगा, बट हु इज हैविंग एडिशनल नॉलेज, एडिशनल स्किल, एडिशनल स्पेशलाइजेशन, आई विल सर्च फॉर दैट. सो आज की इंडस्ट्री को यही चाहिए है. नॉर्मल मैकेनिकल इंजीनियर्स, उसके बाद उसको ट्रेनिंग दो, सिखाओ, उतना टाइम किसी के पास नहीं है. So if you have some kind of specialization something, वो कंप्यूटर में भी हो चलेगा, but there should be a specialization. So that specialized subject, I will say condition monitoring is one of the. If you say I have a 90% and no specialized subject, and if you say I have 83% only, but I have vibration analysis level 1 certification, I know vibration. Sir, I know alignment कैसे करते हैं. Sir, I know the oil analysis procedure. Sir, I know some NDT techniques procedure. That 83% will get selected. Why? Because he has some kind of specialized skill, specialized job, or specialized certification. So for that purpose, this condition monitoring is very, very important. So mechanical engineer with a condition monitoring certification, you will surely get a better chance for selection, or always you will be the on positive side कि he will get that job. So कहने का उद्देश्य यही है कि that area specialized subject is condition monitoring, and you should always go for a advanced skills in today's industry. Now, how condition based maintenance works? जो maintenance condition based recommendation से किया जाता है, that is a condition based maintenance, and the prime pillar or the base of condition based maintenance is vibration monitoring. Without a vibration monitoring, you cannot start any condition monitoring program. So vibration monitoring is the most effective tool and can diagnose the 90% of the problems. So vibration monitoring is a very, very basic thing. Just like in hospital also, आपको कहीं पे भी दर्द हो, कुछ भी हो जाए, doctor tries to collect at least one set of heartbeat, और स्टेथोस्कोप से वो एटलीस्ट आपका हार्टबीट चेक करेगा, चाहे आपको कहीं पे भी दर्द हो. Similarly, for a particular machine or any machine, कुछ भी हो जाए, टेम्परेचर 5 डिग्री बढ़ गया हो, कोई एबनॉर्मल साउंड आता रहेगा, फिल्टर चोकअप हो गया हो, या फिर एनी अदर इश्यूज आर देयर, we try to collect at least one set of vibration readings for that particular machine. That will give us a forward path कि किस तरह से आगे बढ़ना है. Then the process parameters, temperature, pressure, flow, input, load, RPM, noise, these are all process parameters, and that also helps us कि वाइब्रेशन बढ़ा तो किसी टेम्परेचर में चेंजेस है, फ्लो में कोई डेविएशन है, आरपीएम में चेंजेस है, मोटर के करंट में कोई हंटिंग है. Such kind of things are very, very important. Then the Liouville analysis, the biggest friend of vibration analysis. Whenever there is a doubt, the Liouville analysis clears that. My gearbox has a sound, my gearbox has a high vibration, but I cannot conclude कि bearing damage है या gear में problem. At that time, the Liouville analysis, just like a blood test. डॉक्टर के सामने दो पेशेंट हैं, 102, एक को बुखार है, एक को 101 है. He cannot directly tell, 101 you are malaria and 102 you are a dengue person. No, he will go for a blood test, and after the blood test he will confirm, oh, 102 having a viral fever and 101 is having a dengue or typhoid, whatever. So Lubal analysis is a must tool for which helps or clears the doubts. Then the condition monitoring services, whenever you will get a time, the balancing of the machines, alignment of the machines, um, to keep the vibration levels on lower sides. Okay, so vibration monitoring will tell you which machine needs a balancing, which machine needs alignment, and accordingly you have to perform during the opportunity. Then the training part is very important. A competent person has to be there for the data collection, for the analysis, for the review, for the auditing, and all these things. So a competent person will, you should have a proper training, और जो भी कुछ नया चीज आता रहेगा, he should adopt it. If it is applicable to your plant, adopt it, take a trial, and then permanently you start the monitoring process. Now, simplifying this, so what is the condition-based maintenance? A scheme whereby maintenance, inspection, and overall of the plant machinery is scheduled on the basis of condition of that plant. This requires techniques of condition monitoring. And what is the condition monitoring? The science of determining the condition of plant by of machinery by non-invasive means during the normal operation of the equipment. मीन्स रनिंग कंडीशन में हम लोग को उस मशीन से डेटा कलेक्ट करना है, एंड यू हैव टू डिसाइड which machines need a maintenance, inspection, or overhaul. I'll give you example. Suppose you are a maintenance in charge and your management ने आपको दे दिया है 20 days, 40 machines and 20 people. Go and start the maintenance. How will you start? उस 20 लोगों में से भी 7 people are from housekeeping, 3 are fitters, 2 are motor expert, 2 are gearbox expert, 2 are pump expert, 2 are the supervisors. How will you start the maintenance? 20 machines, sorry, 40 machines, 20 days. You cannot start the maintenance. You need a condition monitoring data. Out of 40 machines, 15 needs normal general cleaning. I will depute my all the housekeeping people and I tell them 15 दिन में हो जाना चाहिए. Gear experts, 5 gear boxes, I will depute them there. 10 मशीन का अलाइनमेंट करना है, I will depute there. 5 का मोटर में काम करना है, I will depute the motor expert there. Okay, so in this way I will distribute, means skilled manpower, or I can say competent person will work on the particular job. Means housekeeping person will not work on the gearbox, and the gearbox expert will not go with the housekeeping people. So manpower utilization, manpower skill utilization और unnecessary maintenance भी avoid होगा. सारे मशीन्स को आप खोल के बैठ जाओगे, that is not the solution. So जिस मशीन पे ज्यादा ध्यान देना है आप वहां पे ज्यादा ध्यान दे सकते हैं, जिस मशीन पे लेस टाइम स्पेंड करना है, you can do like that also. And every resources can be utilized in a full swing, but you should have a background condition monitoring data for the particular machines. So ये कब possible होगा? ये possible होगा during the running condition. You have to collect the data. Now, तो ट्रेडिशनल बाथटब जो है कि अर्ली फेलियर एट द टाइम ऑफ इंस्टॉलेशन हो सकता है, अदरवाइज द नॉर्मल इंसिडेंट, नॉर्मल पीरियड जो है ऑपरेटिंग का मशीन का वो है, एंड देन द प्रिवेंटिव मेंटेनेंस. बट with that preventive maintenance, if you add up the condition based maintenance, you add the condition monitoring technique data, then the life of equipment will surely increase. Now, at our plant, the coordinated condition monitoring is as a key maintenance management practice we have adopted. Means what कि हम एक ही टेक्निक के ऊपर डेटा, एक ही टेक्निक का डेटा पे ऊपर रिलाय नहीं करते. We collect the maximum data, whatever we can collect from our machine, we collect. Means if from a particular machine we can collect the vibration, we will take. Oil analysis, we will go for that. Noise analysis, we will collect the data. Ultrasonic, we will collect the data, and any deviation in any parameter, we will look for that. Okay, so coordinated condition monitoring is a key maintenance practice. Equipments are prioritized for the close monitoring on the basis of criticality index to ensure high plant availability. Means जो machines ज़्यादा critical है उसके लिए ज़्यादा monitoring होगा, जो machines less critical है उनके लिए कम monitoring होगा. Means what? The turbine, very important and prime auxiliary, you can say, in any power plant. So we'll monitor on the daily basis. Then pumps, standby available hai, we'll monitor it weekly. दो standby available है fortnightly. As and when means कोयले का रेक आया and that machines are running monthly. Some service water pumps है bi-monthly. So in this way we monitor, just like a human body. So critical equipments are monitored more attentively to further improve the maintenance as well as operational performance. Critical equipments के ऊपर हमारा ज़्यादा से ज़्यादा ध्यान होता है. So for that system also we have installed the online vibration continuous monitoring system. So critical equipments are monitored very closely, because if they fail, there is a direct impact on the plant and the plant will get tripped. जो लेस क्रिटिकल है उनके थोड़ा सा हम लोग कम मॉनिटरिंग करते हैं, लेकिन मॉनिटरिंग जरूर करते हैं. दैट इज अ पार्ट ऑफ प्लांट. ऐसे नहीं कि इनको छोड़ देते हैं, बट वी मॉनिटर दैट आल्सो very क्लोजली. जस्ट अ मोमेंट. क्रिटिकल एंड इंपॉर्टेंट मशीन्स के बारे में एक एग्जांपल देता हूं कि सपोज इट्स 10 o'clock in the night. ओके, आपके इस उंगली के यहाँ पे दर्द हो रहा है. ओके, so what will you do? You will take a painkiller or put a झंडू बाम and okay, सुबह देखते हैं चलेगा. ओके, you'll not go for a surgeon. अरे उंगली में दर्द है, मैं रात को कैसे सोऊंगा. So I will take care in the morning. चलेगा. ओके, इसका मॉनिटरिंग देखेंगे सुबह. But if there is 11 o'clock or 12 o'clock, there is a problem in your heart, what will you do? Painkiller or surgeon? Of course, the surgeon. So the criticality changes. कि आपको पता है कि if my heart fails, everything is gone. Okay, so critical equipments monitoring is very important, and लेस क्रिटिकल और जिनका डायरेक्ट इम्पैक्ट नहीं है जनरेशन के ऊपर, उनको हम लोग थोड़ा समय से मॉनिटरिंग करते हैं. So online monitoring for the critical machines and offline monitoring for the all machines. critical machines का हम लोग ऑफलाइन रीडिंग लेते ही हैं, बट एक कंटिन्यूस ऑनलाइन सिस्टम भी उसके ऊपर इंस्टॉल्ड होता है कि सेंसर कंटिन्यूसली इज मॉनिटरिंग, और रात के 2 बजे भी या फिर ऑड टाइमिंग्स में भी कोई डेविएशन आता है तो मुझे पता चलना चाहिए, बिकॉज इट्स क्रिटिकल. इट विल डायरेक्टली इम्पैक्ट ऑन माय जनरेशन. प्लांट को ट्रिप कर सकता है. सो द मोस्ट इंपॉर्टेंट मशीन्स, दैट इज टर्बाइन जनरेटर, क्रिटिकल पंप्स, बीएफपी, सीईपी, इंपॉर्टेंट फैंस, आईडीएफडी, पीए fans, coal mills and coal conveyors. So these are the very important machines that needs a continuous 24/7 monitoring. Okay, and remaining machines को हम लोग ऑफलाइन मॉनिटरिंग में हम लोग खुद जाते हैं, मशीन के पास सेंसर लगा के उससे रीडिंग लेते हैं. So I will show you some snaps of online vibration monitoring. So in this way, this is a critical AHU system for the DCS system cooling. Okay, so this is a sensor mounted on the bearing. The cable is going connected to this system, and you can see the display outside the machine. So no need to go to the machine. Okay, from the outside only you can monitor the machine, monitor the trend and everything. Any deviation in any parameter, वहाँ पे हम लोगों ने एक बोर्ड भी लगा के रखा है कि इसमें कुछ वैल्यू यदि बढ़ता है तो immediately inform us, then we will see what is the problem. Some more critical systems installed on the coal mills. उसका ऑटोमेटिक ट्रेंड भी जनरेट होता है, ऑपरेटर के लिए वैल्यू भी दिखाई देगी, ट्रेंड also get generated, और लिमिट के बाहर वैल्यू जब जाता है, so at that time on a big TV screen sequence of events में आपको in a sentence आएगा कि yes there is a problem with coal mill ND bearing in axial direction, just look at them with a buzzer sound and everything will be get alert. We'll find out then what is the problem in the particular machine. Now this is all about condition based maintenance and what is condition monitoring. Now condition monitoring techniques I'm going to just show you. I cannot teach you because it takes 3 to 4 days. Okay, each and every technique. So for the HODs, for the professors and for the students, everybody has a role here. सबके लिए कुछ ना कुछ मैं कहना यहाँ पे चाहता हूँ. Condition monitoring is a doctor's job. So just like a doctor, यदि आपके सामने कोई डॉक्टर को इंट्रोड्यूस कर रहा है कि this is a doctor or he is doctor or she is doctor, आप इमीडिएटली क्या क्वेश्चन पूछोगे? ओके डॉक्टर है, लेकिन कौन सा डॉक्टर है? देन ही विल एक्सप्लेन और शी विल एक्सप्लेन, यस I am an eye surgeon, I am a heart surgeon, I am a bone specialist, I am a gynec, or I am a heart neurologist, or whatever. मुझे इतना ही आता है. Similarly, if you say I am a condition monitoring analyst, in which field you have a specialization. So just like a doctor's field, whatever the body parts are there, every area जितने भी बॉडी पार्ट्स है, ईच एंड एवरी एरिया का स्पेशलाइजेशन अवेलेबल है. हार्ट सर्जन हो, आई सर्जन हो, ENT स्पेशलिस्ट हो, बोन स्पेशलिस्ट हो, whatever. Similarly, in a condition monitoring techniques, lot of fields are there, and in each and every field you can go for a specialization. So wide opening of the doors for your study. Vibration monitoring and institute balancing, structural health monitoring, WDA and chemical analysis, noise and ultrasonic monitoring, motor current, thermography, dissolved gas analysis. Each and every technique you can go for a specialization. सारे इसमें specialization नहीं करना है. Only the one which you are interested. Somebody may ask कि किस फील्ड में मैं जाऊं? I will always give the example of cricket. जब आप क्रिकेट खेलने जाते हो, who tells you you are a good batsman? Who tells you you are a good bowler or wicket keeper or fielder? Nobody tells you. आपको अंदर से ही पता होता है, I am a bowler, I will take a wicket. I am a batsman, I will hit a 4 or boundary. I am a fielder, I will save this, and I am a wicket keeper, I will keep the wickets. Similarly, आपको जिस भी फील्ड में इंटरेस्ट हो, you can go for a specialization. So starting from the students, if you are really interested in a condition monitoring field, then with your basic mechanical engineering or electrical engineering, civil or any field engineering, if you are interested in any field, you can go with that. Okay, for the professors, you can also guide your students, and you can also select any field specialization and go for a PhD. I will glad to announce that yesterday only one professor from Chile Engineering College has awarded the PhD in coordinated condition monitoring and increasing the reliability and availability of the plant. He worked with me from 2015 to 19. Whenever he got the chance, he came to the plant and done the PhD. And yesterday only he got, means my first student got a PhD, though I am not a PhD person. So for the professors, you can go for PhD also, and the HODs or the college deans or the big people, I will say. Okay, you can also introduce such kind of topic which industry needs, because no college has any facility of condition monitoring topic. So you can introduce step by step any topic in your college, and whatever the industry is needed, you can start the certification process. Whatever help or guidance, I will always there. So as a board member of condition monitoring society of India, it's my prime responsibility to guide the people who are really interested in the condition monitoring field. So these are the various techniques. I will show just photographs of each and every technique. So these are the techniques where these are done during the routine condition monitoring activities. Means machine chal raha hai and you will collect the data from the machines. So what is that? Vibration, simply back and forth movement of machines and machine components. It is a pump, motor, or board belts, or vibrating fans. Okay, sorry. So these are the advanced Web50 analyzers currently we are using. Okay, the sensor is attached to the bearing point, the cable is connected to the vibration analyzer, and we take the reading from the machine, and we analyze that, we trend it, we study the spectrum, and any fault is there, we simply tell the maintenance team. Where we take the data? We take the data in three directions, that is the horizontal, vertical, and axial direction. Okay, and for the vertical machines, vertical direction will be the inter direction of discharge. These are all level 1 details. Okay, whenever we get a chance in future, I can explain you in a cartoon format. Okay, all the animations and videos are there. So vibration analysis can help you detecting all the kind of faults, means unbalance, misalignment, looseness. एग्जैक्ट फॉल्ट नहीं भी बताया तो भी एक रास्ते पे आपको छोड़ देगा वाइब्रेशन कि यस, in this path or on this path or in this direction the fault arises or fault has developed. Okay, so unbalance, misalignment, looseness, bearing defect, gear defects, electrical, belt, resonance, aerodynamic, hydraulic for problems. Each and every problem can be identified with the vibration analysis. Now जिसको वाइब्रेशन आ गया समझ में, he can do the in situ balancing. Okay, for this the phase analysis is very important. That is another part of the analysis. Okay, so in situ balancing is always there. And one more important thing कि vibration या फिर लेवल कंडीशन मॉनिटरिंग सर्टिफिकेशन के बाद आपको जॉब ही करना है ऐसा नहीं है. यू कैन गो फॉर योर ओन बिजनेस आल्सो. ओके, सो इन सिटू बैलेंसिंग भी आप सीख सकते हो एंड यू कैन गो फॉर बैलेंसिंग आल्सो. सो there is a good rates available for the balancing jobs also. Okay, now for the civil people, the structural health monitoring is a new job or new idea. Or without structural health monitoring, आपको स्ट्रक्चरल हेल्थ मॉनिटरिंग पहले सोचना है, उसके बाद ब्रिज बनाना है या बिल्डिंग बनाना है. ओके, सो there is a concrete vibration sensor available. Okay, this is a patented technology by IIT Delhi, Dr. Suresh Balla. Okay, I met him in University of Huddersfield. Okay, so at that time he introduced this sensor. So you can simply install inside the beam Aesthetically also it looks good, and you can connect with a oscilloscope, digital micrometer, and you can again take the data in pen drive also. For the steel structures monitoring, the piezo patch is available, and I-beams or big structures can be monitored. Means this piezo patch is this one, just like a SIM card of your mobile phone. ऊपर से ग्लू डाल दीजिए, दो केबल बाहर आ जाएगा, कनेक्ट कर दीजिए, एंड यू कैन ऑलवेज मॉनिटर द हेल्दीनेस ऑफ योर स्ट्रक्चर्स. यहाँ पे भी simply this portion goes inside the concrete section, and this cable is coming out from that sensor, and you can always connect and get the readings whatever you want. Okay, in this way some more snaps for you. So steel structure and concrete structures can be monitored easily with the piezoelectric sensors or concrete vibration sensors. Then chemical and variability analysis. Chemical analysis is a normal analysis, means viscosity, density, moisture, NAS level. With that, you can find out how my oil condition is. Variability analysis is higher version. The oil inside the gearbox, how are my components? Means component का कंडीशन कैसा है, ये हम लोगों को वेरिएबल्स एनालिसिस से पता चलता है. एंड सम मोर एडिशनल टेस्ट आर आल्सो देयर कि हाउ मच ऑयल टॉप अप इज रिक्वायर्ड इन बिग टैंक्स, और कितने साल कितने दिनों तक मैं इस सेंसर को ऑयल को यूज कर सकता हूँ. दैट टेस्ट आर आल्सो अवेलेबल. सो chemical analysis and variables analysis is very very important. So these are the advanced tests, that is the RPOT test and ruler test. Rotating pressure vessel oxidation and remaining useful life of evaluation routine. Then the demulsibility, foaming stability, and rust prevention. These are all advanced tests we are doing for the turbine oil condition monitoring. Then the noise and ultrasonic. These are very very important supportive techniques. You can always use. You can always go for specialization. Then the most advanced technique, that is the motor current signature analysis, only for the electrical people. Okay, so मोटर आपका प्लांट में कहीं भी होने दीजिए, I can check the motor from the control room, and I will find out whether how is my rotor bar condition. Thermography, widely used. Whenever there is a access, you can use this. Okay, some people think that thermography only is for electrical people. No, yes, electrical के लिए ये तो बहुत बड़ा एडवांस टेक्निक है, बट यू कैन फाइंड आउट द बेल्ट लूजनेस और टाइटनेस. एयरक्राफ्ट इंडस्ट्री भी यूज कर रहा है, टैंक में सेडिमेंट है या नहीं, पाइप में कहीं चोकिंग है क्या. ऑल दिस थिंग्स कैन बी आइडेंटिफाइड यूजिंग द थर्मोग्राफी. सो थर्मोग्राफी का यूज भी बहुत बड़ा है. And the last one is dissolved gas analysis, that is a DGA. Transformer oil testing. So my transformer oil condition is in what way, or because of the contaminated oil my internal parts may get damaged. So to avoid this, unwanted gas formation is in what concentration, all these question answers can be find out with the help of dissolved gas analysis. So the oil testing plays a vital role and clearly gives an indication whether I should go for a replacement or not. Now these are all techniques I said already कि ये सब हम रनिंग कंडीशन में कर सकते हैं. इफ माय मशीन इज इन शट डाउन, मैंने टरबाइन खोल के रख दिया है, जनरेटर साइड में निकाल के रख दिया है, बेरिंग खोल दिया है, देन कंडीशन मॉनिटरिंग पर्सन को कोई काम है या नहीं है. Yes, he has always a job. So he has some more techniques, and in these also you can go for a specialization. Level 1, level 2, level 3, level 4. What is level 1? A data collector. Data has to be collected from a perfect location. कहीं से भी data नहीं लेना है. The sensors are not smart. आपने सेंसर फ्लोर पे रख दिया, यू विल गेट अ रीडिंग. आपने सेंसर वॉल पे लगा दिया, यू विल गेट अ रीडिंग. आपने सेंसर मशीन के बेरिंग पे लगा दिया, यू विल गेट अ रीडिंग. Sensor does not recognizes where I am. Okay, it's level 1 engineer's responsibility to keep the sensor at correct location and collect the data. लेवल 2 मीन्स लेवल 1 जो डेटा लेके आया है उसका एनालिसिस करना. लेवल 3 मीन्स लेवल 2 का एनालिसिस रिव्यू करना, केस स्टडी बनाना, प्रेजेंटेशन देना. लेवल 1 एंड लेवल 2 को हमेशा गाइड करना. लेवल 4 मीन्स that is scientist level. You can create some innovations and vibrations or condition monitoring audits and all these things. So level 1 2 you'll get a good job. Okay, now during these tests are done during the machine stop condition. Machine is not running at that time. Routine condition monitoring activities during the shutdown. RSO test for the generator rotor to check shorted turns, earth fault, interturn faults, rotor high resistance areas under generator rotor winding. So इसमें क्या है कि हम लोग दो सोर्स देते हैं एनालाइजर से, and they should follow a same path. If there is no same path followed by the sources, then there is a problem with your generator rotor. For the stator, the LC test, that is the electromagnetic core imperfection detection test for the generator stator. So generator stator leakage current should be less than 100 milliamps. Okay. So if it is on a higher side, तो कहाँ पे क्लीनिंग करना है, कहाँ पे रिपेयर करना है, कहाँ पे मटेरियल फिलिंग करना है कोर में, ये सारा चीज वहाँ पे डिसाइड होता है. एंड द लीकेज करंट इज ब्रॉट and below 100. Natural frequency test of the generator. जो overhung portion है, this overhung portion because of vibration during running condition may get a loose or may get wedges may get loose. So because of that the bars may get loose. So to avoid this the NFT test is done and any looseness will immediately corrected during the shutdown. Then the magnetic particle inspection, that is the MPI test for the LP turbine blades. So LP turbine blades surface cracks are identified. There is a long procedure for each and every blade. Okay, cleaning of the blade, um, first sandblasting of the rotor, cleaning of the blade, then the applying magnetic field, spraying the magnetic particles, viewing under the UV light. Sorry, sandblasting of the rotor, cleaning of the blades, applying magnetism to the blade, magnetic particle spray. Under the UV light, you have to see all the blades in all directions. If there is a crack, you will get a clear line on the blade. If there is no crack, then the particles will be seen in a sprayed manner. And the final step, demagnetization of the blade. So to check the surface crack, all 380 blades, you have to perform similar procedure. Okay, it's a 70-hour job. Natural frequency test of the LP turbine blades. Once the MPI test clears the blade is installed on the turbine and the natural frequency test is done. So looseness at the roots, overheating, uneven heating can be identified using the NFT test of the LP turbine blades. Then the LPT test, any surface crack can be identified as per the ISO standard 1417E. Okay, so liquid penetration test is done and a detailed procedure is 6 steps are there. So okay, so cleaning, applying the penetrant, excess removal after 15 minutes, then applying the developer, seeing, inspection and cleaning, post cleaning. So to detect the surface cracks of various critical materials, parts of turbine and generator. Why these NDT techniques are done? Because whenever we remove these critical parts, you cannot just throw away, or you cannot directly use without testing. You have to confirm whether my part is for good or bad, any abnormality is there, or all is correct. So to ensure all these things, these tests are very necessary. Ultrasonic tests to detect the cracks which are located inside the material. Okay, LPT test is for surface cracks. This ultrasonic test is for the inside cracks. Okay, so ultrasonic analyzers are there, and you can do the testing using the piezo sensors, and you can detect the faults. In turbine bearing, disbonding can be detected with the help of ultrasonic testing. These are the thrust pads. You can detect the disbonding. Okay, then the radiography testing. Industrial radiography is modality of non-destructive testing, uses the ionizing radiation. Okay, it plays an important role in the science and technology needed to ensure product quality and reliability. Generally, we check during the generally we go check radiograph testing is done for the turbine blade. Sorry, not for the turbine blades, boiler welding joints. Okay, there are huge welding is done inside the boiler, and to ensure the healthiness, quality work, the radiography testing is done. So in this way, the setup is there. It is based on principle that the radiation is absorbed and scattered as it passes through the object, and on the film you can clearly see if there is any flaws or any problem is there. And the last one is AD current testing for the condenser and heat exchangers. So condenser and heat exchangers, after 2 years of operation, when you open, so choking is there. So jet washing, chemical cleaning, and if any blockage is there, you have to clear that, or permanently you have to bypass it. So all these decisions are taken by doing the AD current testing for the condenser and heat exchangers to increase the efficiency of the system. So to check the healthiness of condenser and heat exchanger tubes, AD current testing is done during the shutdown. So these are all tests or techniques available for an mechanical engineer, electrical engineer, or any other engineer. He can go for a specialization. ज़्यादा खर्चा नहीं आता है. You have to for the NDT techniques you can perform always. South के engineering colleges में by default these programs are taken up, and जब भी वो mechanical engineer होके निकलते हैं बाहर, so such kind of additional certifications they have from their college. They arrange such kind of programs at their colleges. Okay, so NDT techniques ज़्यादा ये नहीं है, कोई बड़ी बात नहीं है. You can always start from your college. At least LPT, UT और MPI भी चालू कर दिया तो बहुत बड़ी बात है. So each and every technique का हम लोगों ने एक शेड्यूल बनाया हुआ है. Okay, and we follow the 52-week schedule rigorously. Each and every technique we included, each and every machine we included, and we follow all the SOPs, and with this technique we ensure our healthiness of machines. Okay, so our machine healthiness during running condition and during shutdown we ensure with the help of these techniques. Now some more techniques for the electrical, means electrical condition monitoring program में मैं just बताना चाहूँगा कि थर्मो विजन स्कैनिंग जो है उसका एरिया कितना वास्ट है. मैं जस्ट एक दिखाना चाह रहा हूँ 220 केवी स्विच यार्ड है, ट्रांसफॉर्मर है, ST-LT मोटर है, स्विच गियर्स है, जनरेटर बस डक्ट है, ओके, क्रिटिकल LT मोटर्स है। देन टेक्निक्स का नाम सिर्फ सुन लीजिए, LA थर्ड हार्मोनिक रेजिस्टिव लीकेज करंट और स्विच यार्ड एंड ट्रांसफॉर्मर यार्ड, कैपेसिटेंस एंड टैन डेल्टा मेजरमेंट ऑल एरियाज, CB डायनेमिक कॉन्टैक्ट रेजिस्टेंस मेजरमेंट, CB टाइमिंग है, कॉन्टैक्ट रेजिस्टेंस में स्विच यार्ड के लिए बहुत सारा टेक्निक्स हम लोग यूज करते हैं। ये सारा क्यों कर रहे हैं कि कोई भी फॉल्ट यदि आना चाहता हो तो हम लोग को पहले ही पता चल जाए, ओके, सो दैट वी विल बी रेडी विद मैन मटेरियल एंड एवरीथिंग। ऑनलाइन कर सकते तो ऑनलाइन करेंगे, अदरवाइज प्लान्ड वे में शटडाउन लेके काम करेंगे। ऑनलाइन PID, मोटर करंट सिग्नेचर एनालिसिस, डिसॉल्व गैस, स्वीप फ्रीक्वेंसी, LCD एंड RSO हम लोगों ने ऑलरेडी बात किया है। सो ऑल दिस टेक्निक्स वी इंश्योर ऑल आवर इलेक्ट्रिकल सिस्टम्स हेल्दीनेस। नाउ हम लोगों ने कुछ नया इनिशिएटिव्स भी लिया है कंडीशन मॉनिटरिंग टीम ने, कि सब लोग अभी स्मार्ट मींस IoT की बात करते हैं और क्लाउड बेस्ड टेक्नोलॉजी की बात करते हैं, तो हमने भी इन हाउस कुछ बनाया है। सो हमारा एग्जिस्टिंग ऑनलाइन वाइब्रेशन सिस्टम था, उसको हम लोगों ने एक वायरलेस ट्रांसमीटर के साथ कनेक्ट कर दिया, और कनेक्ट करने के बाद this was the online system and the sensor is installed to the transmitter, लोकल ऑपरेटर के लिए अवेलेबल है। इसको एक कनेक्ट कर दिया हम लोगों ने वेब बेस्ड वायरलेस कनेक्ट ट्रांसमीटर के साथ, एंड वी कैन सी आवर डेटा ऑन अ डेडिकेटेड वेबसाइट विच इज अ पासवर्ड प्रोटेक्टेड, ओके। सो हम लोगों ने एक वेंडर का भी मदद लिया है इसमें। सो ऑन दिस वेबसाइट we can clearly see our vibration trend, monthly reports, yearly reports or quarterly reports, whatever, और कोई भी डेविएशन आता है तो हम लोग को तुरंत उसमें पता चलता है। नाउ नेक्स्ट जेन के बारे में हम लोग नई बात करेंगे, बिकॉज आई वांट टू शो यू सम केस स्टडीज। नाउ कंडीशन बेस्ड मेंटेनेंस साइकिल, तो हमारे प्लांट में ये कैसे काम करता है? द कंडीशन बेस्ड मेंटेनेंस साइकिल वर्क्स पीरियोडिक मॉनिटरिंग, जो एज पर शेड्यूल मैंने दिखाया, देन द मॉनिटरिंग ऑन कॉल। मॉनिटरिंग ऑन कॉल मीन्स किसी ऑपरेटर ने बोल दिया कि मुझे यहाँ पे आवाज लग रहा है, 5 डिग्री टेम्परेचर बढ़ गया है, या कुछ तो फ्लो में डिस्टरबेंस आ रहा है, फिल्टर बार बार चोक हो रहा है, या फिर मोटर करंट में हंटिंग है। If such kind of observations are there, then what will happen? We do the monitoring. कोई डेविएशन नहीं है तो we close this chapter immediately. But if there is a deviation, we analyze the problem by close monitoring, repair को schedule करते हैं और carry out the maintenance. We adjust the alarm levels after the maintenance work. So in this way, मीन्स पीरियोडिक मॉनिटरिंग एंड मॉनिटरिंग ऑन कॉल। यदि कोई डेविएशन नहीं है तो कोई प्रॉब्लम नहीं, बट डेविएशन है देन हम लोग रिपेयर शेड्यूल करते हैं एंड मेंटेनेंस वर्क कैरी आउट करते हैं एंड अलार्म लेवल्स अकॉर्डिंगली एडजस्ट करते हैं। देन वर्किंग विद सेफ्टी, नॉट यूजिंग अ मोबाइल फोन व्हाइल टेकिंग रीडिंग्स, कीपिंग द टॉर्च विद वाइब्रेशन एनालाइजर, यूज ऑफ PP, दिस प्राइम चीजें हैं, छोटी छोटी चीजें हैं, लेकिन ऑलवेज, बिकॉज I say mobile is the biggest enemy of person. कोई भी काम करते टाइम यदि हम मोबाइल यूज कर रहे हैं then there is a risk, okay, और मशीन्स के पास काम करते टाइम तो very big risk. So this kind of things has to be avoided. सर एक 2 मिनट्स का ब्रेक लेते हैं सर।
ओके सर, नो प्रॉब्लम।
2 मिनट्स ब्रेक, उसके बाद मैं कुछ केस स्टडीज के साथ बात करूंगा।
ओके सर, नो प्रॉब्लम।
Thanks for the break. So let us
Yes, sir.
continue. Yeah,
Yes, okay, sir.
I will show you 2 to 3 case studies. Okay, so whatever I have discussed with you regarding the condition-based maintenance or condition maintenance cycle and all various techniques. So I will show you the via case studies how we implementing and how we are finding the faults, how we are executing the maintenance action, and how we are getting benefited. Okay, केस स्टडीज में बहुत सारा नया टर्म्स भी आपको सुनने को मिलेगा. जस्ट इग्नोर देम बिकॉज मैंने आपको कुछ भी सिखाया नहीं है. आई हैव नॉट, आई हैव जस्ट informed you how in industry condition monitoring plays a vital role. Now, the first case study, boiler feed pump misalignment. So our boiler feed pump is in this way. So main pump motor is coupled with a booster pump and hydraulic coupling step up and main pump. Total 8 bearings are there. Only 6 number and 7 number bearing is having a high vibration. So vibration में trend में हम लोगों ने देखा कि 3.4 से 5.1 and 1.1 से 1.7 the vibration level deviated. We studied the vibration spectrum and suspected that misalignment हो सकता है. We are not confirmed. To confirm the misalignment, we carry out the phase analysis. So phase analysis, हम लोगों ने phase readings लिया, stroboscope connected to the vibration analyzer, and from that we got the phase readings. So across the coupling we got 180 degrees phase difference. So whenever there is a across the coupling, दो bearing के बीच में 180 degree का phase difference है, then we confirm that there is a misalignment between that two things. Once it is confirmed, immediately that pump was stopped, standby was taken in service, और हम लोगों ने alignment check किया. 0.3 mm radially disturb मिला. We found out the root cause. दो बेरिंग कपलिंग के बीच में एक स्पेसर होता है जिसमें रबर का फ्लेक्सिबल एलिमेंट्स होते हैं. So 2 to 3 got damage and some got crack. Okay, हम लोगों ने 10 साल से उसको रिप्लेस नहीं किया था. It's what time. This is a sacrificing agent, just like a bush of the other type of couplings. Okay, so we replace this part with a new one, new flexible coupling elements, and alignment was done. See the result. The vibration reduced from 5.1 to 2.2, 1.7 to 1.1. यदि ये पंप ट्रिप होता तो प्लांट भी ट्रिप होने का चांसेस था. वो हमने नहीं होने दिया, और हाई वाइब्रेशन की वजह से जो सबसे छोटा बेयरिंग है बूस्टर पंप का, वो हम लोगों ने डैमेज नहीं होने दिया. उसका कॉस्ट भी 1 लाख रुपीस के आसपास है. सो जस्ट टाइमली हम लोगों ने डिटेक्ट कर लिया, और 8 बेरिंग में से सिर्फ एक बेरिंग के एक डायरेक्शन में रीडिंग बढ़ने से ही हम लोगों ने तुरंत एक्शन लेके उसको एलिमिनेट कर दिया. Now, main cooling water pump, motor bearing looseness. So these are the biggest pump of our plant, slow speed pumps. Okay, 16 pole motor, 2 pole motor, 3000 rpm. This is a 297 rpm 16 pole motor, specialized motor. Okay, 34 ton motor. What इसका काम क्या है कि ये पानी खींचता है सी से, समंदर से, और टरबाइन के कंडेंसर कूलिंग के लिए जाता है. ओके, सो व्हाट हैपेंड, vibration level increased from 3.8 to 101 microns. Gradually increase, एक ही दिन में नहीं बढ़ा. 30 micron, 40 micron, we keep close on the vibration readings. Okay, so 100 micron was the limit and 101 was recorded, and we stopped the pump. Pump reading was normal, 29 microns. We studied the spectrum and seen that multiples were there. 1x, 2, 3, 4, 5, 6. These are the multiples. So what these multiples conclude? These are revealed that there is an increase in multiple of running speed harmonics 1x, 2x raised up to 8x, which suspected the looseness of the motor bearing. And high displacement value also confirmed that there is a bearing looseness. Immediately we decided to replace the motor. So gear coupling found okay between motor and pump bearing clearance is checked okay, means no secondary damages. Alignment found disturbed due to increased clearances, accepted. हम लोगों ने स्पेयर मोटर के साथ रिप्लेस किया. ओके, मॉड्यूलर कॉन्सेप्ट जस्ट लाइक अ पंक्चर टायर कॉन्सेप्ट. ओके, टायर पंक्चर होने के बाद हम लोग स्टेपनी निकालते हैं, लगा देते हैं और बाद में अच्छी जगह जाके उसको बनाते हैं या फिर पंक्चर को रिपेयर करते हैं. सो सिमिलरली we never do the maintenance of faulty part or damaged part on the spot. हम लोग पहले मशीन को अवेलेबल करते हैं, देन द क्वालिटी मेंटेनेंस करते हैं, क्योंकि काम का कोई प्रेशर नहीं होता है. मशीन चालू है, कोई काम का प्रेशर नहीं है, आप क्वालिटी से मेंटेनेंस कर सकते हैं. आफ्टर रिप्लेसिंग द मोटर सी द रिजल्ट्स. 101 से हम लोग को 3.4 माइक्रॉन्स रीडिंग्स रिड्यूस हो गए. पंप वाइब्रेशन रिमेन अनचेंज्ड अगेंस्ट द लिमिट ऑफ 75 माइक्रॉन्स. सो कहने का उद्देश्य यही है कि vibration monitoring and spectrum analysis played a vital role. Okay, so यदि ये पंप हाई वाइब्रेशन की वजह से ट्रिप हो जाता था या डैमेज हो जाता था मोटर को, तो पर आवर 9 लाख रुपीस का हम लोगों को लॉस हो सकता था. सो दीज आर द वेरी क्रिटिकल मशीन्स. आई विल शो यू वन थर्मोग्राफी केस स्टडी. थर्मोग्राफी का इसमें शायद नहीं. 1 मिनट. ओके, थर्मोग्राफी का केस स्टडी भी मैं दिखा देता हूँ आपको. ये मैंने बोला है तो दिखा देता हूँ. ओके, बीएफपी. इसमें क्या हुआ कि ड्यूरिंग रूटीन मॉनिटरिंग वी गॉट अ हॉटस्पॉट. ओके, at neutral terminal box. So this is the necktie photograph and this is the thermography with a hotspot. So 97 degree was the highest temperature we got. We compared with the other running BFP and that was absolutely normal. So by seeing the deviation, we immediately stopped this and found and opened that neutral terminal box, and B phase neutral connector found overrated. Immediately we replaced that, and after replacing, the temperature reduced to 40 degrees centigrade. So thermography is very vital to even CRH01 panel MCB. Here also we got a high temperature. After replacing that, the temperature reduced to 35, means from 164 degree to 35 degree. So such kind of hotspot also important. Thermography is an important tool to identify the hotspot, and timely action will save your panels or your motor or any other part of the area. Now the last case study I want to show you, that is a coordinated condition monitoring technique. The last one. Yes, this one. Okay. I monitored this machine for 9 months. Okay. Now, coordinated condition monitoring technique, and on this case study only, my student or the professor of Geel Engineering College got a PhD. So he studied this machine a lot than me. Okay, I just detected the fault, but he studied a lot. This was the history for 9 months. I will show you step by step. So pre-maintenance history, what happened? The acceleration value was increased from 2.4 to 3.1 and no deviation in any parameters of hydraulic coupling. We compared for similar machines. We have similar 4 fans. So for hydraulic coupling 2A, the acceleration value was on higher side. We suspected a bearing damage. Immediately we sent the oil for the wear debris analysis and found 68 micron bearing particle. For other hydraulic couplings of other fans, no bearing particles. This was a great achievement for us, okay, to confirm the fault. Here 68 micron was available, and for other fans there was no bearing particle was available. We took the ultrasonic reading, found deviated from 3 to 6. We monitored for some months. Meanwhile, the acceleration increased from 3.1 to 3.8, and in the month of August, 3.8 to 4.2. Then the vibration increased. Then the noise, uh, hydraulic coupling fan horizontal increase from 0.7 to 1.0, and in the month of September the vibration also increased from 2.9 to 7.7. So all parameter increase up to the limit level. Decided to stop the fan for hydraulic coupling replacement. Meanwhile, we have done all the kind of analysis, that vibration, acceleration, ultrasonic and wear debris analysis, deviation was there, and hydraulic coupling replacement work was planned. So in meanwhile 7 to 8 months, what the maintenance department has done, they have kept ready the hydraulic coupling as a spare, serviced, then the expert manpower, any PO was required, then that also, and each and everything, even the hydra and truck availability was also made available, made ready, so that whenever we get a chance, we'll take up this work. Then the vibration analysis. The acceleration value was on higher side, showing the high frequencies. Okay, whenever the non-synchronous value is on a higher side, it's sure shot there is the bearing defects. So whenever there is a stress waves are generated, metal to metal contact will be there, and passing of roller. Whenever the roller passes through the fault, such kind of impacts are generated. So similar thing was happening in the machine also. So we were decided to replace the hydraulic coupling. During the shutdown, we stopped the fan. Alignment between hydraulic coupling and fan found disturbed because of increased bearing clearances. Minus 90, minus 80. This has to be minus 70. No scoring marks on motor, fan shaft. Thorough inspection of both D and D bearing was done, means no secondary damages. Fan internal inspection was done, no deviations noticed. So hydraulic coupling decoupled from rest of the dry group and oil was drained. New serviced hydraulic coupling was placed, aligned with the motor and fan. Fresh oil filling done. Motor to hydraulic coupling to fan was alignment was done, and see the results. The acceleration was 4.2 initially, means before replacing, reduced to 1.2. Okay, and here 1.9 to 0.5. Online readings also reduced to the normal, 4.2 to 0.9. Ultrasonic readings also reduced from 6 to 3 LEDs. And the most important parameters, the oil analysis, 68 micron bearing particles after replacing and 1 month operation, the bearing particles are not there. So this machine has no standby available. If this machine fails, then we have to stop the plant and complete loss is there. एक आईडी फैन पे प्लांट चलाना बहुत मुश्किल है. Okay, so this is a very critical system, and secondary damage to motor and fan was avoided. सिर्फ हम लोगों ने coordinated condition monitoring से ये करके दिखाया, और the application of coordinated condition monitoring helped diagnosing the exact root cause of abnormality well in advance and guided the plant engineer to plan the maintenance work during nearest available opportunity with no generation loss. So these are all the case studies I have discussed with you, and कंडीशन मॉनिटरिंग के लिए टाइम कितना भी दीजिए वो कम ही है, बट आई ट्राइड माय लेवल बेस्ट टू जस्ट एटलीस्ट आज आपको माय एम इज you should you are able to know at least what is condition monitoring, कि कुछ तो अलग टॉपिक आज हम लोगों को सुनने को मिला. In nearby future, full-fledged program can be arranged with your permission, with your interest. Okay, and any questions? I'm ready to answer. Please, sir.
Hello. Sir, there are few questions. May I ask?
Yes.
Okay, sir. So first question is from one of the participant. He is asking, which
Thoda,
chart?
please increase your voice volume because I am unable to hear.
Okay, can you hear, sir, now?
Yeah.
Okay. Sir, the question is, which charts or guidelines are used for standard acceptable vibration levels while doing the vibration spectrum analysis?
Which standard?
Which charts or guidelines are followed?
Okay. Charts or guidelines means ISO 10816-1. Okay, ISO 10816-1. This standard is used, that is the readings taken on non-rotating part of the rotating machines, and for the analysis purposes. Okay, for the analysis purposes the standard charts are available, but still you always cannot rely on that. You have to be practice for that. The reference standards are available. You can ask for on Google also, you can search it, or if you are really interested somebody, you can directly email me. I'll give my email IDs are also available with all of you, and you can directly mail me or WhatsApp me. You can always get the charts, no problem.
Thank you, sir. So the second question is, sir, you talked about smart condition monitoring in between. So one of the participant is asking, can we use machine learning or big data analytics for condition monitoring?
Yes, you can always use, because if you can enter all the machine data, means what is the RPM, what is the load, what is type of coupling, what kind of foundation, what kind of bearings are used in your particular machine, then you can enter this data once. Then if there is a variable data, you can also enter that particular software, and you can give the input of vibration, temperature, pressure, flow, or your process parameters, oil parameters, and on that basis you can define your alarms, you can define your trip limits, you can define the whenever go for a maintenance or any other action. And pre means charts you can also mention कि इस type का spectrum आ रहा है, then what kind of tentative fault will be there. Okay, so such kind of things can be entered, and with this data analysis you can get a ready-made solution, and you can do the smart monitoring of the particular machine.
Thank you, sir. These are the only questions from participants, sir. So
Okay.
Now I will propose vote of thanks, sir.
Thank you.
Sir, it is my privilege to propose vote of thanks on this occasion. I, Professor Ashwini Gotmare, on behalf of MCT's Rajiv Gandhi Institute of Technology, Department of Mechanical Engineering, and on behalf of the organizing committee of AICT AQIS sponsored 1 week short-term training program on recent trends in energy management and audit. And on my own behalf, I extend a very hearty vote of thanks to Mr. Hemant Bari sir for accepting our invitation as a resource person and sparing his valuable time with us. Sir has given really good insights on the topic of condition monitoring practices, and he has helped us to understand it with case studies also. Thank you so much, sir. Tomorrow, participants at 10:30 a.m., we have a session with another resource person, Mr. Panduranga Jalkote, sir, on energy conservation initiatives at DTPS and learnings from Japan. So we are looking forward for your participation. Thank you, sir. Thank you so much.
Thank
Now
you.
I request our technical team that we can officially end the meeting.